What about the web platform? So web platform normally contains all the layers but the application layer. Okay, so that will be, of course, the some hardware, some firmware between it and the operating system, and then some web server software that basically will mm, provide this transport and logical interface through the network. Yeah, so it will establish SSL connections and TCP connections, and will get the data through in order for client and web application to be able to interoperate. Okay, to just throw packets at one another. Uh, and of course, these web servers can be separated with the web application logic, yeah, web application software, by this thing that is called application server. So that's not a web server, but it contains some functionality that is implementing web server functions, yeah, but it's something more than that. It's just like the collection of sandboxes, like somehow virtualized environments for different web applications that are run within this application server. So they share some functionality. Of course, they share functionality of accessing network and reading writing socket ports in the operating system. Yeah, so that is all shared between them, but the business logic is encapsulated in every separate web application, yeah, separately on that layer, but commonly on the below layers. So there are different types of application servers, but they have not identical but very similar infrastructure models. So they have some process that is just virtualizing some resources for all the web applications that are run within it. Okay, so for example, if you have like 10 web applications that are run on a Tomcat application server, most probably they all will use the same operating system user account that is called Tomcat. So they will have access only to this directory structure on the file system that belongs to that Tomcat user. So once you somehow compromise one of them, you cannot get normally, without any escalation exploitation in the operating system, will not be able to break out of the jail. But that's still possible and becomes more and more possible with time, unless the Tomcat and the operating system under it is constantly and properly updated for security vulnerabilities. Okay, what else? We have that thing, database management systems. Yeah, so that's something that is on a deep backend. Yeah, as we said, and that is responsible for storing, retrieving, and keeping the data in order. Okay, and there are two like general types of that. However, yeah, let's eat that in small pieces. So first, there is this relational database model that is like table based. Okay, what is relational? We have tables and we have some relations between them. So we have tables for names, we have tables for last names, and we have a table that like links the last names and names together, inputs them into a relation that is basically identifying a human being. Okay, so they have values, they have keys, they have unique keys, they have indexes that make the search operations much faster. So this is relational, and normally relational databases are accessed through SQL, so by using SQL language. Yeah, that is more or less human-like. Yeah, so it has some logical structures that are familiar to a normal human being. And there is this family, I would say, of non-relational databases that are simply named NoSQL databases as well, but they are really different. Okay, so there is not a single type of non-relational database. So relational is a family of different database management software and database management concepts and systems, but non-relational is really a class. It's a collection of classes, yeah, of data management principles and software that implements them. So we can imagine that as anything but not tables. Okay, that can be trees, for example. Yeah, so LDAP is an example of non-relational database indeed. Yeah, so it's like the tree that has a common root, and then it has different objects in the root, and then they split into the branches, and those branches split into further more branches, and then until and so on and so forth until the end, that is called the leaf, that can contain a table structure, tabled data in it, but until that point it's still a tree. Okay, so it's not a table at all at upper levels. Or that can be a document. Okay, it can be an XML document, and it still is a database. It stores and keeps the data in order, and allows requests to it, search requests, for example, or update requests. So it's like a fully functional database, but it doesn't use any tables. It uses the XML document structure. It has some XML schema somewhere, and everything works well, and even better than relational databases in some specific edge cases, like the situations when you really need to scale that database really fast on demand and then contract it back at the same pace or even faster when the data becomes unneeded. Okay, and a few words about cloud environment. So that's a really broad and vast topic by itself. It doesn't fit into anything in these video tutorials, right? But you can virtually imagine that as something that can substitute an operating system, a web server system, or application server layer, yeah, in the platform, in the architecture, or even just substitute the web application as a whole. Okay, so let's say you want to deploy your web application in the cloud. There are different ways to do that. You can virtualize, you can like cloudify, or what is there a word like that? I'm not sure. You can you can use the cloud component at different levels of abstraction. So SaaS, yeah, that software as a service concept, that means that you make your whole application available in the cloud. So it's just accessed by humans right away. You don't have to do anything, yeah, in order to link your clients, your users, and your software. Yeah, you don't have to put anything in between. So if it's Gmail or Dropbox or other type of application, it's already SaaS. So user just comes and starts using it right away. If it's platform as a service, though, you have to install that somewhere, and then these PaaS components are available to you. So you like install your web application, but the database that you use is available to you. You don't have to install it on some separate host into this exact host where you host your web application. Okay, so you have this platform as a service. Yeah, so every platform components like web server, application server, and database server are available to you. You just put the credentials into your web application, configure it to use those platform components, and you're done. And infrastructure as a service is the lowest level of abstraction that is provided to you in the cloud. So it's like just giving you a operating system, a host with an IP, like a virtual machine basically in the cloud, that you can then configure from the ground up by all the components on the platform level, and then install your software on it, yeah, and then you're done. So the most work, but at the same time the most level of the most amount of control over what you've just done. Okay. And there are popular choices of that in the market. Of course, Amazon Web Services is maybe more convenient for business, yeah, so it's like really comprehensive at the moment. It allows the most functionality, and it allows the most broad choice of security tools as well. But if you are more like a startup kind of business or team, and you want this trial and error path to be taken and build your application from the ground up, yeah, like from scratch, maybe you will be interested in something more hipster. Okay, so something like DigitalOcean that just gives you some platform components, or just a pure untouched operating system, and then when you really need that scalability, you move it to some more I'm trying to avoid the word mature, but let it be the more mature cloud. Okay, so this is how the architecture works. There are different components, there are different layers. The below layers, of course, are explicitly trusted by the above layers, and yeah, I hope this fits the overall picture of security principles and methods that are already in your head well. Okay, yeah, let's go. Let's go review all of them one by one and see how we can attack each layer of this infrastructure separately and in combinations.